Hey everybody, welcome back. It's been a few months since my last video, but I've been busy with things and I'm glad to have an update for you guys. In the last video we introduced the Scuff-EM software and how it can calculate Casimir forces and torques on different geometries. It was really cool because what we were able to learn is that nested polygons will realign themselves so that they're, well, I guess not aligned, they're perfectly unaligned. But now that we kind of got a good feel for how to use the software, we're going to focus on an L-shaped object interacting with a wall of varying curvature. Okay, so the optimization study here that we did, it was kind of a parametric study. We have different radius values for this wall. We have a gap value, and our leg values will vary between 90 degrees, 75 degrees, 60, and so on, getting smaller and smaller. And then the leg return height here was held constant at 2, so things get kind of weird at 15 degrees, but that's okay. Typical mesh configuration looked like this. You see we got refinement right here, really good refinement, a little bit more refinement on the edge, just it's mostly for this case and maybe this case a little bit. These ones are getting so far away from the other elements that it's probably not making much of a difference. This is the typical configuration for a 5-unit radius on the curved wall. So yeah, that was a typical setup. The results, the optimum situation is basically right here. The best angle was 90 degrees. The best radius was 1,000 units, which basically puts us very close to a flat wall on a flat elbow, so basically the plates are parallel, which kind of makes sense. Let's see here. So yeah, so we're going to use these concepts here, the optimum angle, optimum radius. We're going to use this information to develop a new nanostructure that will hopefully give us an optimized torque value, at least a decent amount of torque. So what's next is we're going to develop a 3D surface mesh for a physical object. The analysis, we're going to include all the Casimir forces and torques for all directions. We will also be refining the mesh as necessary to verify that we've a model that converged. We might use custom frequency files just to make sure we're not missing anything. And then once we have these forces, we're going to consider friction, because if friction kills everything, then this thing's not going to work. So if we've got the forces and torques, we should be able to figure out what kind of safety factor we have. Well, I guess it's not really a safety factor, but what kind of how much more torque we generate than the friction that would be stopping it. And so once we know that, we'll either have to redesign because there's too much friction, or we'll have some level of confidence that it will generate motion. So yeah, that'll be the next step. Thanks for watching. Go ahead and leave any questions in the comments. I'm still cranking on these models, trying to get them to work, trying to get them optimized, trying to see what kind of design changes I can make to really crank the torque up to its maximum value. And yeah, I'll be in touch.